There you go. So we are live. Okay.
All right. So we're all
so far, I think we're all good. We talked about that it was a lot of vocabulary and a lot less formulas. Kyla, do you have any questions about the first part?
No.
No? Okay. So, 2, they have us randomly select 5 of the 30 salaries and compute the mean. I wrote down which ones I used and then what my number was. I used numbers 1, 7, 13, 19, and 5. Miranda, do you know which ones you used?
I have to be honest, I actually didn't write down the ones that I used. I just kind of picked them out of a bag and put them into a calculator. But my mean, after I did that, was
okay. What was your 46,600?
And 40.
Okay, I had 44,740. Hyla, what did you have?
See, that part I didn't do. I got lazy.
So
that part.
Okay, all you need to do is pick 5, add them together, divide by 5. Miranda, is that what you did? You pick 5 and divide by the number.
Yep.
And that's how you find the mean. Okay.
Yep. Randomly select 5, and so yeah, I add them together and divide it by 5.
Okay. I have like little notes everywhere.
Yeah. So looking at from the prep assignment, looking at the graph, I mean 46,000 was what I had, and mine's pretty much, I mean, not right in the center, but pretty close.
Yeah, I was just slightly left of center. Yeah, so I was just I was a little more left than you were, but I'm still under or within the curve. I'm not sure how you want to translate it. So
yeah.
I think probably what we would all find, although we all could have used different numbers, all 4 of us could use different numbers, there's enough of them, that we would still end up under the curve.
Yeah, I would say so.
And then C said, does your sample mean appear to be unusual, and explain why you think it is or is not? And I said the sample mean seems to be normal because I the mean of the graph, and then I posted my number and said it was within 2,000 of the graph mean. So, and then D, I'm sorry, my headphones have like a kink in them that's driving me. D says, compare your mean from question 7A to the mean attained by at least 2 other individuals. What do you notice? In practice, you only get to see the mean from the sample you draw. You do not get to observe any other means. So, I mean, other than I think we all fall under the curve, do you guys have anything else you want to put in or comment? Anything?
No.
Nope, we pretty much got it.
So, hey Miranda, you want to do question 8?
Oh, sure. So the graduate management admission test is used as an admission criterion in many Masters of Business Administration programs. The scores on the GMAT are normally distributed with a mean of 529 and a standard deviation of 113. Consider a simple random sample or n equals 10 students taking the GMAT. What is the shape of the distribution of the sample means for all such samples? Well, 8. What is this? Oh yeah, what is the shape? It says normally distributed in there.
Well, and I think as long as you remember that if they're telling you that originally it's normal, then it continues to be normal. So I was kind of, in fact, my redundant. It's like normal because the scores were normally distributed. I was like, okay, that makes no sense. So I'll do C. What is the mean of the sampling distribution of sample mean scores for all such samples? And I have 529. I think sometimes I get flustered because I see like these graduate management admission tests, like these big words, and actually have nothing to do at all with the equation. They're just in there. And I think sometimes that throws me off more than the actual equation. So,
yep.
So
I think that's what throws me off too.
So I try to look at the mean, the standard deviation, and whatever else they're giving us. And I try to stay away from anything that is not part of the question. So D is what is the standard deviation of the mean scores for all such samples? And I have 113 divided by the square root of 10, which is 35.734.
That's, yeah.
Yeah, I think that's what I got too. I have 35.733, but I don't know why I rounded differently than you. But
don't worry about it. Okay, so I'm gonna make Emily gets here soon. I know that they've had snow this week in Rexburg, so if she's coming from the IF, she may be a little bit slower. I have a frog in my throat. I'm sorry. And I'm just gonna I'm writing down roll real quick. Hey Miranda, what's your
Garza?
Garza, okay. So I know I have to put it on the thing. And then I was gonna ask, I forget what it was. Shh. What was my question? I don't remember. Okay, do we want to do the are you guys ready to do the quiz?
Yeah.
I'm ready.
Okay. Let's go ahead and open our quiz. My computer wants to update.
Remote. Bobby put it in here.
I'm just hoping that
See that.
I can get through this before the whole reset thing. Miranda, where do you live?
What?
Whereabouts do you live?
I live for now. Because I'm actually at my cousin's house, and I'm only telling you because you don't know me really. I mean, you know who I am, but
I just meant like Colorado.
So I live in Modesto. Well, I live in Escalon, California, which is near Modesto. I don't know if you've heard of Modesto.
I grew up in Southern California, so it's familiar. So, okay. Are we about ready to start? Let's see. How many questions do we have? We have 12 questions.
Not bad.
And the first 2 are done. So.
Oh yeah, so technically it's 10.
Yeah. So, okay. I'll read the first question. When you're taking a sample size of n equals 5, distribution of means histogram when the parent population is right skewed. And I in my opinion, that right skewed or skewed right, because if your parent is skewed one direction, then you would be skewed that. Is that correct?
Yes, I would say so, especially because the sample size is so small. So it's not like it would be changed to normal. So I would say skewed right.
See, that
I
my
would
issue is
too.
I know that it says if the parent population is normal, the sampling will always be normally distributed. But I don't feel like we talked about if it goes one way or the other. So, and for some, this chapter is so tiny this time. So, okay. So, who would like to read? Anybody want to read question?
I'll read it.
Okay, go for it.
When you are taking a sample size of n equals 100, what is the shape of the distribution means histogram when the parent population is right skewed? I would say skewed right.
Well, I would say skewed right too, except, like I said, for the question, previous question, there's that rule that whenever a population or sample size is large or considered large, that it's considered normal shape. But I don't know
that's
what's
true.
considered large.
Well, is this something we should plug into the applet to see? Because they give us the applet in the beginning. While you're required to work together, it says if needed, here's a link to the applet.
I don't know, just because I don't know how I would even use the applet, because
Yeah, that's my thought was the same thing.
Yeah.
Glance through the chapter to see.
yeah.
I'm wondering if it's normal whether or not.
Yeah, same here.
I'm wondering if they're supposed to be normal, because that is the only thing that the chapter is normal or approximately normal. So I'm thinking, in my opinion, I'm thinking that it's supposed to be normal because it says parent population is normal, the sampling is normal. If the parent population is, if the parent population is not normal, then the sampling distribution will be approximately normally distributed if the sample is. So with the first question where it says the sample size was 5, I would think it would be right skewed because 5 is really small. But where they say the sample size is 100, I'm thinking that might constitute being big enough.
I think it is.
Because here it says, oh, go ahead, Miranda.
Oh, no, sorry. I was just going to say here, I'm reading, for most moderately skewed distributions, a sample size of around 30 is traditionally thought to be sufficiently large to assure that the shape will be approximately normally distributed.
So I'm thinking question 4 is going to be normal.
I think so too.
Yeah, I think so too.
So 3, 3 is skewed right, 4 is normal. Oh.
Right.
Hey, Emily, we are on. I'm so sorry, Mike. You're fine. We're on question 5 of the quiz.
Okay.
So if you want to pop your quiz up.
Yeah.
So the first two are whether you're participating and whether or not you did the prep. And then when you read the questions on the quiz, question 3 talks about the distribution mean and whether or not which skew it would be. They say the parent population. So we went with right skewed because 5 is a small number. And then on question 4, it mentions 100 looking for the distribution of means. And we said that we thought that would be skewed normal because in the chapter it talks about a sample size is at least 30. We will conclude the sampling distribution would be approximately normal. So 100 is substantially larger than 30, so we went with normal, which brings us to question 5.
Are you there, or are you still trying to get there?
I'm good.
Or you can just write stuff down. Question 5. Anybody want to read question 5? When you are taking a sample equals 5, what is the shape of the distribution of means histogram when the parent population is normally distributed? So it would be normal.
Normal? Yeah.
That's
Does
what I
everybody?
said. I agree.
See, then I second guess myself because I'm like, is this too simple? Like, am I?
I'm thinking the same thing. I'm like, why is this not? Sometimes I think harder. And then I'm like, don't ask that question because it'll get harder. So anybody want to read 6?
I could read it.
Okay, go ahead, go for it.
When you are taking a sample size of n equals 100, what is the shape of the distribution of means histogram when the parent population is normally distributed?
So if
Since
it's normal to say,
since the parent population is normally distributed, would it be normal?
That's what I would think.
I agree.
I think that makes sense.
Okay.
Okay. Then
I can read that.
awesome, thank you.
7. When would the distribution of means be normally distributed? Choose all correct responses. So the first one, data are drawn from a population that is normally distributed and the sample size is small. Data are drawn from a population that is normally distributed and the sample size is large. Data are drawn from a population that sample size is small, or data are drawn from a population that is right skewed and the sample size is large. So,
I would think 1, 2, and 4. Because it has to have a large sample size to sort of recorrect itself from right skewed. So I would think number 3 would not, because it says it's a small sample size and it's right skewed. Whereas number 4, or the 4th one says data from a large population. So I would say 1, 2, and 4.
That's what I think too.
That's what I think too.
Okay. Number 8. I'll do number 8. Which of the following gives the best explanation of if the parent population from which the data is drawn is normally distributed, the sample mean will follow a normal distribution. For bell-shaped data, approximately 68% of the data will be within 1 standard deviation of the mean, 95% of the data will be within 2 standard deviation of the mean, and approximately 99.7% of the data will be within 3 standard deviations of the mean. Or, if the sample size is large, sample be close to population mean. Or, if the sample size is large, the shape of the distribution of sample means will be approximately normal.
It's the last one. It's that
So
one.
we are looking for central limit theorem. And
It's if
according,
the sample,
go ahead.
it's if the sample size is large, the shape of the distribution of the sample means will be approximately normal. Anyway, that's what I wrote down on the from our key points.
So if the sample size is large, the sample mean, wait a minute, will be approximately normal.
Yeah.
So you're saying number,
Normal.
I mean, I think that's what I would put as the best description of what that means, because I feel like
yeah.
some of the
That's
other
what I
ones
put
are,
down.
I feel like the other ones are true, but I feel like as far as, or some of the other ones are true, but I feel like as far as the central limit theorem goes, that last one is the best definition.
The last one is really, really close to the exact wording in the summary section of the chapter.
Yeah, it
Yeah.
is.
So I agree. So, okay. Anybody want to read it?
I'll read it.
Okay, awesome.
Well, I'll read the stuff before it too. Let X be a random variable with population mean of 10 and population standard deviation of 6. Suppose the sample of size n equals 36 is drawn from this population. What is the mean of the distribution of sample means?
The mean of the sample means.
What is the mean of the distribution? So the mean would be 10. It's the same as the parent population.
Yeah, it tells us right there.
Okay.
Okay.
And then the next question is, what is the standard deviation of the distribution of sample of means? And this is where you take the standard deviation divided by the square root of, where's my thing? The square root of, so it would be 6 divided by the square root of 36. Is that right?
That sounds
Does that
right.
sound right to you guys? Okay, 6
Yeah.
divided.
Flip my calculator.
So 1?
So I would say 1. I haven't even done the math yet, and I'm, okay, 6 divided by 6.
The square root.
I'm looking at 6 divided, excuse me, 6, because the square root of 36 is 6, so wouldn't it be, oh,
That's what I got. The standard deviation is 36 divided by the, 6 divided by the square root of 36, which is 6. 6 divided by 6 is 1.
Yeah, that makes sense. It took me a second to realize how simple it was.
That's me with this whole lesson. I'm like, wait, is that?
I'm like, they just put it in a lot of words.
Yeah, that's what it did a lot this lesson.
okay, so, question, anybody want to do question? 11 and 12, I just glanced at them, are pretty, so regarding the population, if the sample size is larger than 30, what would be the shape or distribution of the sample mean? So we're talking about a large sample size.
It'll be normal.
I would say normal. And then what by your response, I would say this, I would limit theorem, because the central limit theorem is distribution of sample means is normal when X is normally when, thanks to the central limit theorem, our sample size is large.
That's what I would think.
Okay.
Yeah.
And this concludes the fun quiz of the evening.
So what is the last one?
It's when what theorem would justify your response to the last question, where we said with a large sample size, we would have a normal distribution. And so looking at the summary section of the chapter, distribution of sample means is normal when X is normally distributed, or when, thanks to central limit theorem, our sample size is large. Off of talking about a large sample size, we said number 12 is central limit theorem.
Okay.
We shall submit.
Yep.
I don't like how you have like, I feel like I have 15 buttons, but I'm getting used to it. And,
All right.
okay. How'd we do? We got 100%.
Yay!
Congratulations, everyone. I'm sorry. I'm driving me nuts, and I've been sick, and so I'm tired and a little loopy. And my
No,
daughter
you're
said, she's like, "Are you sure you can do this?" I was like, "Sure, I can do that." I don't need sleep. So, okay. So we are all done, and I'll turn in our link. Oh, and very shortly, I'll turn off our live broadcast. Anyways, who would like to do the meeting on Thursday?
I can start us.
Miranda, awesome. I'm going to write this down because I forget, and then I get frazzled that it might be me, and I'm not going to do it. So I'll get all this in just a minute, and Miranda will invite us all to the party next time.
All right.
Okay,
awesome.
guys. We'll see you all next week.
We'll see ya.
Thursday.